Hey everyone, welcome to question 25. So question 25 is one of those questions where we need to give a full explanation, and actually 25, 26, and 27 are ones where we're going to show our work. In part 25, we don't have a lot of space here, so I might need to kind of open up a new piece of paper, and you might need to write this somewhere other than right under 25 because there's not a lot of space. So consider the following the claim. Consider the following claim. If the point 2 plus d comma y is on the graph of the function f of x equals x times x minus 4, then the point 2 minus d comma y is also on the graph. Use algebra to show that the claim is true. So note here that these points, although they are not numbers, are the same, right? The y value is the same. And so that would mean that assuming this is a parabola, that these points are opposite of each other, because remember, parabolas are symmetrical. And the y values are the same, but the x values are different. And so to use algebra to show that that claim is true, we're going to plug in 2 plus d as x and plug in y as our output. So to do that, I'm going to write 2 plus d times, oh goodness, ooh, please excuse me. Okay, 2 plus d times, instead of x, we wrote 2 plus d. And so then in the parentheses 2, we're going to write 2 plus d minus 4. Okay, equals y. So then this is going to be 2 plus d, and I'm going to go ahead and throw parentheses around that just so that I can establish that. And then 2 and negative 4 we can combine, so that will be negative 2 is going to be d minus 2, or negative 2 plus d, however you want to write that, equals y. When I go ahead and FOIL that, then I'm going to get, let's go ahead and do 2 times d is 2d. 2 times negative 2 is negative 4. Inside d times d is d squared. And then last, d times negative 2 is negative 2d. This means that the 2d and the negative 2d will cancel out, and we'll be left with d squared minus 4 equals y, or negative 4 plus d squared equals y. So whatever I get when I plug in this value should also be the same. So let's try that. If I plug in 2 minus d as x, we get 2 minus d times 2 minus d minus 4 equals y. I'm going to do the same thing I did below, and I'm going to simplify. So I'm going to write this as 2 minus d times, again, we're going to have 2 and negative 4, which is negative 2, so negative 2 minus d equals y. And then now I'm going to go ahead and FOIL this to see what it looks like in standard form. So first is 2 times negative 2 is negative 4. Outer 2 times negative d is negative 2d. Inside, negative d times negative 2 is positive 2d. And then last, negative d times negative d is positive d squared. Now, negative 2d and positive 2d cancel out. And so once again, we're left with negative 4 plus d squared equals y, or d squared minus 4 equals y. So here, all you're doing is substituting in this point 2 plus d as x and 2 minus d as x, and showing then that y equals d squared minus 4 in both scenarios, which means that those must then both be points on the line. All right, so that's the first part. Then the second part says, what is the relationship between x equals 2 and the graph of f of x? Well, this is the graph, right? And so just looking at that, you should recognize what the x-intercepts are. So if I set both of those equal to 0, we have x equals 0 and x equals 4. That means that the vertex is between those two at x equals 2. And so we would say here that this is the line of symmetry. So x equals 2 is the line of symmetry. And this is in the graphing section, so if you wanted to, you could graph it. Let me clear this out. clear out these things here, right? So we can clear that out, and I can plug that in and say x times x minus 4, and let's graph, right? So let me go ahead and do zoom 6 standard. Okay, so here, as I said, we have a point that is, our x-intercept is 0 here and 4 here, which means our vertex would be at 2, x equals 2. And so this right here is our axis of symmetry. So x equals 2 is the line of symmetry, and you can explain that you know that because the x-intercepts are 0 and 4, and that means that the vertex and the line of symmetry must be between 0 and 4 at x equals 2. All right, so again, let me show you in 25, this is what it looks like. Sample student response that would get a 4 is if 2 plus d comma y is on the graph, then if we plug in 2 plus d, so they did exactly what I said, and then we get d squared minus 4, which I showed you, right? Because when we FOIL this, that's what we'll get. And so then with the first one, d squared minus 4 equals y. On the second one then, same thing, if we plug in 2 minus d for x, we get an output that is the same as when we put in 2 plus d. And so that is the way that we show that because y equals y, the point 2 plus d comma y is on the graph of f, and so is 2 minus d comma y. And then the line of x equals 2 is the line of symmetry for the graph of f. I know this because the x values are the same distance, absolute value d, from 2 yield equal y values in the function. So you can relate it back to, right, in this instance, they are relating it back to the fact that if we use 2 plus d and 2 minus d, we're going to get the same output for y. So you can use that. Notice it says the student may appeal to the formula, and you might justify that the addresses the point pairs on either side of the line, right? Again, using those x-intercepts, for example, would be another way that you could justify what x equals 2 means in this situation. All right, let's look at at number 26. So some of my writing is here, but we're looking at this right here. The Water Watch program is encouraging customers to reduce the amount of water they use each day. The program is selling low-flow shower heads, which use 2 gallons of water per minute for $54 each. A family currently has a shower head that uses 5 gallons of water per minute and is considering replacing it with one of the low-flow shower heads. The family uses the shower an average of 20 minutes per day and pays 0.002 cents per gallon of water. Create a model that can be used to determine the cost savings in dollars for the family to purchase and use a low-flow shower head in terms of the number of days. Then determine the number of days at which the family will start saving money. Justify your answer in terms of the context. All right, so there's actually a couple ways to tackle this problem. I'm going to show you the way that they recommend we do this. And so we're going to start by looking at each day, right? So this is a function of days. And I lost my little pen thing here. Okay. This is a function of days. And so we're going to have f of d, right? A function of days. And that's going to be our savings. So that represents our savings. And we have to spend $54 on this. So we're not saving any money if we're spending $54. We're actually losing $54 of our money, right? So minus 54 because that's how much I have to give to buy this new shower head. Then I will be, instead of using 5 gallons of water per minute, using 2 gallons of water per minute, which means that I'll be saving 3 gallons of water per minute. So this will be represented as, I'm going to write 3 gallons of water per minute, right, is how much we'll be saving, times 20 minutes on average, right, is going to be 60 gallons per minute saved per day, right? And then money-wise, that's 0.002 cents per gallon of water. So if we want to find out how much we're spending there, it would be 60 times 0.002, that's how much 12 cents a day that we would be saving, okay? So this would be plus the amount that we're saving is 0.12 times the number of days. Okay, so that has us set up with our equation. So this tells me how much I'm saving per day, right, based on the number of days. And then it asks me, well, when will they start saving money? Well, they'll start saving money when they break even, right? So after they break even, then they're going to start to save money, right? So it's $54, right, is how much the cost is. So I need to be above $54, right? And so negative 54 plus 0.12d equals 0. When I finally hit that breaking point, then I know I'll have made it, right? So this will be 0.12d equals, I'm going to add 54 to both sides using my inverse operations. And then I'm going to divide by 12 cents. So 54 divided by 0.12 is 450 days. So it's going to take me 450 days to break even. And so after 450 days of using my new low flow shower head, which is over a year, no longer new, I'll start to save money with a shower head. So it might take some time, but we'll eventually get to breaking even with that cost of $54. So you can explain here, the family will have saved $54 and made up for the cost of the shower head after 450 days. And so after 450 days, they will actually start to save money because they are no longer spending or using, I believe it was 5 gallons of water per minute instead of 2 gallons of water per minute. Okay, so it says 1 year after the low flow shower head is purchased, the cost of water increases by 5%. So now water costs more money. Create a new model to determine the cost savings in dollars with the increase in the cost of water. Use your model to determine the number of days at which the family will start saving money after the increase in the cost of water. Justify your answer. All right. So this is 1 year after the low flow shower head is purchased, which means they've already been using this shower head for 365 days, right? So now our savings is going to look a little bit different because it's increased by 5%. Well, if our cost is increased by 5%, we have 0.002 is cents per gallon of water, times, it's increasing by 5%, so times 1.05, which is going to be, now the cost is going to be 0.0021 cents, right? Okay, so far our savings has been, if we do f of d, is negative 54 plus 0.12 times 365, right? Because we're doing this for 365 days for 1 year, and now the cost is changing. So instead of this being 12 cents a day that I'm saving, I'm going to be saving, remember, it's 3 gallons of water a day times an average of 20 gallons per day, 20 minutes per day, and times now the new cost, which is 0.0021. All right, so that's going to be 3 times 20 times 0.0021. And so that's going to be 0.126 cents per day. All right, so this is how much I have saved so far by buying this shower head. And then now, after that point, we're looking at saving an amount of, instead of 0.12 cents, 0.126 cents. So my savings now is 0.126 cents per day. So I have sunk costs, spent $54 plus saved 12 cents times 365, which is 43.8. So negative 54 plus 43.8 is going to be negative 10.2 plus 0.126 times the number of days, okay? So 12.6 cents, right, or 1.26 cents, right? So now we're looking at a new equation, and now it wants us to know, well, how long will it take us to break even now that we have increased the water? So determine the number of days at which the family will start saving money after the increase of water. So after this change, after a year, how much longer is it going to take? So again, we're going to set that equal to 0. And this time we'll have 0.126D equals, I'm going to add 10.2 to both sides. And then I'm going to divide both sides by 0.126. And so we get D equals 80.95. We would round that up to 81 days. So it's going to take an additional 81 days, which is less than that overall 450, right? But still going to take quite another amount of time for us to actually save that much money. So I'm going to write this as 81 days. Okay? All right. So again, here we're looking at how much they will have, spent for that shower head, plus the amount they will have saved for 365 days. And so that'll give us the new amount that we had spent, our sunk cost that we spent on this. And then we calculated our new cost per day for using not our new cost per day, but our new savings per day of that shower head. And then determined when will we break even. Okay? All right. Number 27 says, if A is a non-zero real number, and A times x minus 3 squared minus B equals C, prove that x equals 3 plus or minus the square root of B plus C divided by A. Show your work. And then it says, if A equals 2 and B equals 5, determine what conditions on C will restrict the solutions for x to real numbers. Explain your reasoning, enter your proof, your answer, and explanation in the space provided. So it says, prove that x equals this. So here's our equation. A times x minus 3 squared minus b equals c. What we're really doing here is solving for x, right? So this is the same as a literal equation. I'm first going to add b to both sides. I will get a times x minus 3 squared equals c plus b. Then, before I can take the square root, remember our next order of operation is multiply, divide. So I'm going to divide by a. Now I need to take the square root. So I'm going to take the square root of both sides and the whole thing, including that denominator. So I'll get x minus 3 equals the square root of c plus b over a. Then I need to add 3 to both sides. So now I'm going to have x equals 3 plus or minus, because remember, when we take the square root of something, it's plus or minus. I should have written that up there. So 3 plus or minus the square root of c plus b over a. All right, so that's just showing your steps, right? That means you're just going to need to show your steps of how you got to this equation, how you got to the solution. Then it says if a equals 2 and b equals 5. So let's go ahead and change that. If we have 2 times x minus 3 squared, make sure I do this right, minus b, so minus 5, equals c. What are the structures that I would need to have in place in order for c to become a real, for x to be a real number, okay? So what I would need to do here then is I'm going to add 5 to both sides, right? And what you're essentially doing is the same thing that you just did above, where you have x minus 3 squared equals c plus 5 divided by 2, right? So now we want to know, when we take the square root of this number, how can I make this a real number? Well, in order for me to make a real number, I need to have it be a square root, right? A perfect square. And so situations in which I can make this a perfect square would be if I can get the answer to be 4, for example. So if c were to equal 3, for example, 3 plus 5 is 8. 8 divided by 2 is 4. the square root of 4 is plus or minus 2. So that would give us a very real rational number. Versus if I were to do 1, 1 plus 5 is 6, 6 divided by 2 is 3. Taking the square root of 3 is going to give us an irrational number. But here it's really asking us, if we go back up, not about rational numbers, but real numbers, which means that inside here, this cannot be a negative number, right? If this becomes negative, then we would be getting an imaginary number. And so that means we have c plus 5 over 2 equals 0. I need it to be greater than or equal to 0. And so then we have c plus 5. If I multiply both sides by 2, this side will just be 0 still. So that means c has to be greater than or equal to negative 5, right? Because if I put a negative 5 in here, that would be 0 divided by 2 is 0. That's fine. And if I put a negative 4 in here, I'll still get a positive answer. But if I were to put something smaller than negative 5, I put negative 6, negative 7 in there, I'm going to get a negative answer, and then therefore it will be a non-real number. So this is testing to see that you understand when we take the square root of a negative number, it gives us an imaginary number or a non-real number. All right, so if you have any questions, please make sure to ask me or reach out to me so that I can go over them with you when we return from the break. Make sure that you have listened and reviewed carefully and that you fully understand how we got these answers. Listen carefully to the explanations. And again, if you have questions, please do reach out.